Hi guys, kung bago ka pa lang sa channel ko, bago ka manood, subscribe mo muna tong YouTube channel ko. Okay? So, ngayon, dito sa video na to, magre-react tayo dun sa isang video ni Engineering Mindset regarding sa ano ba yung pinagkaiba ng tatlo? Nung hot wires, ground wires, tsaka neutral wires. So, maganda yung video dito ni Engineering Mindset. So, puntahan natin. Let us watch kung ano yung pinagkaiba. Then, ito. Ground, neutral, and hot wires explained. Electrical engineering grounding. So, magre-react tayo dito ngayon. Okay? Let's play.
Video is for homes in North America. If you are outside this region,
So, ayan, medyo mahirap intindihin English. Tatagalogin natin simpleng ano lang, layman's term para maintindihan ng lahat. Okay?
then you can still follow along, but your system will work and look a bit different, so do check out our other videos.
Forward na natin. Sa bawat bansa kasi iba-iba ng iba-iba ng color coding. So, iba-iba yung color coding per nitong mga wires na to. Dito sa atin, sa Pilipinas, itong ground, green, neutral, minsan kulay puti. Itong hot wires, RYB. Red, yellow, black or blue kapag three-phase. So, RYB. Pag three-phase system. Okay, proceed na tayo.
Remember, electricity is
Ayan, sabi niya, electricity is dangerous to your health. So, as an electrical engineer or as an licensed electrical practitioner, dapat bago tayo gumalaw sa isang energized na electrical circuit, so dapat alam natin ibig sabihin ng ganitong danger sticker, caution. So, kasi kahit maliit na current, nakakamatay. Electric shock risk.
dangerous and can be fatal. You should
It can be fatal. Yan, sabi niya.
be qualified and competent to carry out any electrical work. Before we get into this video, there are 3 things I need you to remember. Number 1, electricity will only flow in a complete circuit.
So, ayan. Ito yung mga points to remember. Number 1, electricity will only flow in a complete circuit. If you come into contact with an electrical conductor, your body might complete the circuit. So, anong ibig sabihin yan? So, i-drawing natin para mas maintindihan nyo. Read tayo dito. So, ang sabi niya, ang flow of current daw is into complete circuit. Right? So, drawing natin. So, bago ka assuming na ito yung source mo, para makabuo ka ng complete circuit. Alright. Assuming na ito yung load. Yan. Yan yung sinasabing complete circuit. Meron kang source. Meron kang source dito. Tapos meron kang load. So, assuming, kapag itong area na to is na, so kung nakat mo to, ito open yan. Let's say nag-open yan dyan. Let's say ito yung switch. So, maaaring, sabi niya, balik tayo. If you come into contact with an electrical conductor, your body might complete the circuit. So, sinasabi niya yan kapag, halimbawa, this area is na-touch mo. Na-touch ng tao. Yan. So, ikaw, itong tao, let's say it is electrician. So, itong electrician na to, maaaring makomplete niya yung circuit. So, ang flow of current, blue tayo. So, ang magiging flow of current is from here, going to here, tapos papasok sa katawan. going to ground. Then, pabalik sa source. Remember na yung flow of current is, ang tendency niya is bumalik sa source. So, yun yung flow of, niya. So, yung flow of current is from positive to negative. So, pag ganun yung flow of current. So, let's say, itong side na to, parang neutral na to. Tapos, itong side na to, hot. So, kung ito yung load mo, assume na yung load mo is ilaw. No? Okay. So, ayan. Kapag nakaka-open yung switch, pero nahawakan mo dito sa side na to, yung hot wires, maaari yung flow of current sa iyo na dumaan, papunta dito sa source. So, yung ibig sabihin niya. Simple, maaari makomplete yung circuit. Okay? Proceed na tayo. Go!
If you come into contact with an electrical conductor, your body might complete the circuit. Number 2 is that electricity always tries to return to its source.
So ayan, sabi ko na kanina, electricity always tries to return to its source. So, punta tayo dito, yun yung sinasabi kanina. Ang tendency ng current is laging bumalik doon sa kung saan siya nanggaling. Parang ikaw, kung galing kang probinsya, gusto mo lagi pauwi ka ng probinsya. Alright.
Source. And number 3, electricity will take all available paths to complete a circuit, but it will take preference to a path with less resistance, and so more current is going to flow in that path.
So ano yun? Ibig sabihin nitong number 3. Electricity takes all available paths to complete the circuit. It takes preference to path with less resistance and more current will flow in that path. So yung current, naghahanap yan ng mababang resistance. So, let's say in this circuit, kung ikaw yung current nandito sa area na to, itong kulay blue na to, assuming na na-close yung circuit mo dito, so yung current na yan, maghahanap yan ng mas mababang resistance para makabalik sa source. So the less resistance, dun dadaan yung current. Kapag dito, mas mataas yung resistance dito sa ground. So, high resistance dito, hindi siya agad makakabalik dun sa, kasi, may resistance? Yun yung parang pumitigil dun sa flow of current na makabalik dun sa source. Ay, kung ito, dito sa side na to, sa neutral, mas, dito siya magpo-flow. Kasi, mas mababa yung resistance dito, compare dito sa tao na nakahawak. So, ang tendency, kapag nakahawak dyan, since mataas yung resistance, makukuryente to. Mamamatay itong tao na to. Ayan, mukhang patay na nga. Sa drawing pa lang. Okay, balik na tayo dito. Proceed na tayo.
Okay, so we're going to be looking at the hot, neutral and ground wires for a typical North American residential electrical circuit. First, we'll see a really simple circuit to understand how it works. Then we're going to apply this knowledge to a complex.
So, yan, simple lang yung example niya. Ang closed loop circuit is, let's say, meron kang baterya dito, meron kang battery, tapos ang load mo ilaw. So itong hot wires magpo-flow papunta sa load, and then yung neutral, itong white, babalik siya dun sa source, which is the positive side ng battery. So this battery and bulb is basic example ng ground, neutral, and the hot wires. So in this case, ano lang to, hot wires tsaka neutral, wala pa yung ground.
Complex residential installation. When we look at a simple electrical circuit with just a battery and a lamp,
so ito, forward na natin kung na-explain ko na yun.
electrons can flow from the negative. We need to connect another wire, electricity from the power supply, and then we'll take this
Makikita nyo yung direction ng current from hot wires going to neutral.
over to the load. The neutral wire carries the used electricity back to the power supply. If we look at a residential electrical system in North America,
So, in this case, ito, AC system na to. So, you have dalawang line, tapos neutral. So, itong example na to is applicable siya kapag line to neutral. So in this case, line to neutral yung load. So meron kang 2 lines pero tsaka neutral. Pero dito sa atin, 3 phase. So meron kang 3 hot wire tapos isang neutral.
America, then we will find 2 hot wires, a neutral wire, and some ground wires. If you want to see in detail how this all works, then check out our video for that, links in the video description below. Now imagine for a second that the home's electrical system is connected to a battery.
So ano na natin, i-fast forward na natin, medyo mahaba yung discussion na dito. Punta na tayo dun sa main topic. So ayan.
In this circuit is AC alternating current, which is different from the DC direct current which we saw with the battery.
So in this example, dalawang circuit kasi siya. So dito sa circuit na to, this is a direct current example. Okay? And then this one is AC circuit. Meron ka ng transformer at saka ito primary side ng transformer, ito secondary side. So ayan, AC system. Pansin mo yung flow of current dyan alternating. I-play natin.
Current, which is different from the DC direct current which we saw with the battery. With DC, the electrons flow.
So yung DC, direct current, one direction lang yung flow. Doon sa AC, kaya AC, alternating yung current, which is dito sa Pilipinas, ang frequency natin is 60 Hz. So yung alternation ng current hindi na visible sa mata. So mapapansin nyo yung mga ilaw natin, kung i-slow mo yan, medyo ano yan, parang nagbi-blink-blink. Pero sa sobrang bilis, dahil 60 Hz nga, so hindi na siya visible sa mata ng tao.
Flow directly from A to B in only one direction, much like the flow of water down a river. But in our homes, we have AC alternating current, which means the electrons alternate their direction between forwards and backwards, much like the tide of the sea. Now in North America, we have a split phase supply to most residential properties. So we have the 2 hot wires and 1 neutral wire. We simply have 2 120 volt coils which are connected together in the
So dito,
of around 100.
Dito sa example na to is meron tayong dalawang hot wires tsaka isang neutral. So parang line 1 tsaka line 2 tapos may neutral. So yung neutral dito center top ng secondary side ng transformer. Dito sa side na to primary side to
120 volts, and we get the same reading for the other one.
So ayan, 120 yung ma-reading mo dito. Dito sa kabilang side is 120 din. Yung line to neutral.
That's because we're only using half of the coil in the transformer. But then when we connect between the 2 hots, we get 240 volts because we're using the full length of the transformer coil.
Ito, isang coil lang. So yung since center top, so mahahati lang yung dalawa, kaya kanina ang na-reading nila is 120. Parang dito sa Manila, kapag na-reading mo yung kabilang side, line to line. Kapag na-reading mo yung kabilang side, line to neutral, 110 lang. So it's like the same with this.
If you don't have a multimeter, I highly encourage you to get one. Links down below for which one to get and from where. Now,
so itong kapag license electrical practitioner o electrician, engineer, mas maganda meron kayong tester, lalo na yung mga electrician na gumagawa ng mga energized parts. Much better na bago kayo gumalaw, bago kayo safety first muna. Dapat tinetest muna yung mga electrical circuits bago hawakan para safe. It's always better than safe than never. So electrical is very fatal. Hindi pwede na.
Get one, links down below for which one to get and from where. Now, if we have a load on only one half of the coil, and the load is, for example, 20 amps, then the hot wire will carry 20 amps to the load, and the neutral wire will carry 20 amps back to the source. We can measure the current in a cable using a current clamp meter. Again, links down below for which one to get, coil, and the load is a different value.
Kasi mapapansin nyo dito sa example, meron silang dalawang hot wires, tapos may neutral. So, anong purpose ng neutral? Ang purpose ng neutral is to carry the unbalanced load. So, kung meron kang unbalanced load, so yung neutral, pabalik sa neutral, yun yung current niya dun is the difference ng dalawang load. Let's say it is, mamaya may example to. So, ang purpose ng neutral under normal condition, yung unbalanced current sa kanya magpo-flow. So, kung let's say ang isa lang to, isang hot wire taka neutral, dito ka lang may load sa side na to. So, yung magpo-flow na current pabalik sa neutral is kung ang from dito sa hot wire ang nag-flow is 20 amperes, papaganyan. Yan yung na-reading ng clamp ammeter. So, ang babalik din sa neutral is 20 amperes, pabalik din sa source. Pero let's say, meron ka ng load dito sa side na to, sa line 2. So, tapos ito, hindi 20 ampere, hindi siya balance. Ang mangyayari dyan, yung difference ng dalawa, yun yung dadaan sa neutral. I-play natin, may example yun dito.
Say for example, just 15 amps.
Yan. So, yung itong dalawang load, hindi siya balance. Mas mababa itong yung isa 20. So, mapansin nyo yung neutral, siya yung magkikiri ng the difference between these two load. So, under normal condition, yung neutral is pat ng current, unbalanced current.
Then the neutral will only carry the difference between these two values back to the transformer or back to the electrical source. So in this case, one side we have 20 amps and the other side we have 15 amps. So the difference between these is 5 amps. So the neutral will carry 5 amps.
So ayan. So yung neutral, mapapansin nyo, ang mga marireading niya dito. Pwede nyo rin itong i-testing sa actual. Pero dito, with this example. Since yung kabilang line to neutral is 20 amperes, then the other side, line 2 to neutral, 15 amperes yung load. So, hindi balance eh. Kaya yung 5 amperes na difference, siya yung magpo-flow pabalik dun sa neutral. Pabalik sa source.
Where does the rest of this go? Well, it will pass through the two hot wires. Now this is what we have in most cases because there are multiple circuits with different loads in the residential property. However, if we had a load on both coils and they are of equal value, say for example 15 amps each.
So, ano mangyayari kung parehas yung values? Anong babalik sa neutral? Since ano yan, balance, anong babalik sa neutral? So, panoodin natin.
Then there will be no current flowing in the neutral wire. So where's it?
So ayan, sabi niya walang current na magpo-flow sa neutral. Bakit? Kasi yung dalawang dalawang load, line 1 to neutral tsaka line 2 to neutral is balance yung load. So in this case, bihira yung ganitong perfectly balanced sa electrical system. At least meron diyang unbalanced kahit minimal current lang.
It going? Well, it's flowing back and forth on the two hot wires between the load and the source. That's because it's AC alternating current and the transformer is center tapped with a neutral. So while one half is moving forwards, the other half is moving backwards, and the current will flow into.
So yun, sabi niya, since alternating yan, so the other half, kapag papunta dito, kung pa-forward, the other one is pa-backward kasi alternating nga. Atras abante lang yan, atras abante.
To the other circuit instead of back via the neutral. Hopefully that hasn't confused you too much. If it has, then
A lot to take. So, if you don't fully understand, we are moving on.
don't worry about it too much for now. We're going to cover that in a more advanced video. Okay, so the hot wires carry the electrical current from the supplier and over to the load. and the neutral wires carry the electrical current from the load and back to the supply. So what does the
So, fast forward na tayo, medyo mahaba yung kwento niya. Punta na tayo dun sa may ground wire. Okay. So in this case, meron na tayong ground. Kanina neutral tsaka hot wire lang. Sabi, yung hot wire, yun yung line 1, line 2, or line 3. So in this case, magkakaroon na tayo ng ground wire. So alin yung ground wire? Ito wala pa, neutral pa lang to. So
has a very, very low resistance, so electricity will prefer to travel along it because it's easier and can get back quicker. Now if we go back to the simple circuit with a battery and a lamp, if we now run another wire, we run this from the positive terminal over to the lamp and we connect this to the metal of the lamp holder, then this is effectively our ground wire. As you can see, it's
So ayan, this example, since DC circuit to, meron ka ng ground dito. So ano yung purpose naman ng ground? So yan yung tatakil dito.
not being used to carry electricity. If the hot wire touches the metal casing, then the electricity will now flow through the ground wire instead.
So ayan, kapag yung hot wire is let's say itong receptacle mo dito is may metal parts. So kapag yung hot wire nadikit dito sa metal parts na receptacle, so ang purpose ng ground, siya yung mag-carry ng current. Since nawalan siya ng connection, closed loop dito sa neutral, so yung ground wire, yan yung mag-carry ng current pabalik dun sa supply. So parang alternate siya in case of fault. Anong fault ba to? Line to ground fault.
Dead. If the hot wire is connected to both the neutral and the ground, then it will now flow through both wires back to the source. But as the ground wire has less resistance, then more current will flow through it.
So ayan, yung ground wire is lesser resistance. So kaya mas madami yung magpo-flow sa kanya na current. So the less the resistance, the higher flow of current. The higher the resistance, the less the flow of current.
When electricity finds a way to leave its circuit and return to the source
So
through
fast forward na ulit natin, marami ulit siyang kwento. Ito, ano ba itong sinasabi niya? Purpose of ground wire, normal operating condition. So, i-backward natin ang kwento.
coming back to the house, the electricity flows through the hot wire and into the light and then back through the neutral.
So, yan yung sinasabi kanina. Under normal operating condition, yung flow of current from hot wires, so, going to load, and then magbabalik siya dito sa neutral. So, mapapansin nyo, ano ba yung tinatawag na banding? So, dito, sa side na to, yung neutral tsaka ground. Ano siya? Banded. Let's say, ito yung side na to, ito yung panel board mo. Yung neutral tsaka yung ground na magkasama sa bus bar, magka-band. Or otherwise, yung iba naman, may hiwalay na bus bar yung neutral, may hiwalay na bus bar yung ground. Tapos naglalagay na lang ng banding jumper na wire.
But if the hot touches the metal casing, then
So ayan, nagkaroon na tayo ng ground fault. So ngayon, yun na yung function ni ground wire. Pag nagkaroon ng ground fault, siya yung makikiri ng flow of current from hot wire going to ito yung ground mo, since this receptacle or whatever enclosure yan or junction box yan, metal junction box, siya yung magpo-flow yung flow of current from hot pupunta sa ground wire, and then babalik sa bus bar which is connected in neutral, then babalik dun sa source. So ang tendency kapag tataas kasi yung current niyan, since ground fault na yan, Ang mangyayari, ititrip niya na itong circuit breaker na to kasi mag-i-exceed na dun sa rating nung kung ano man yung rating nitong circuit breaker na ito. So kaya siya mag-trip kasi mag-high current yan pag nag-ground fault.
Then it will instead flow through the ground wire, back to the panel, through the bus bar, and then back to the transformer via the neutral wire.
So,
We therefore connect the ground wires to anything that could potentially become a potential part.
So since yun lang naman yung concept ng neutral tsaka ground. Yung neutral, recap tayo. Yung neutral, under normal condition, siya yung magke-carry ng current pabalik sa source. So under ground fault condition, may fault. Let's say nadikit dun sa particular metal enclosure. So, ay kung may nakatap ka naman dun na grounding, babalik yung current, dadaan siya dun sa ground wire, pabalik dun sa source. So kung mag-high current siya, since fault yan, ground fault, instantaneous yung current niyan, biglang tataas. So ang iti-trigger niya yung circuit breaker na mag-trip. So para safe na yung load mo.
Path for electricity to leave its circuit, such as the metal pipes, the metal plates on the light switches, and the outlets of their boxes.
So yan, may mga cases na yung mga lahat ng metal part sa building kinoconnect sa ground para yung static electricity na o kaya let's say yung may ground fault, babalik siya dun sa source. So for safety din yan.
We also need to run one to the outlets because often our appliances are made of metal or they come with a neutral terminal and a
So ayan, so, yan yung tinatawag na grounding type outlet or 3-prong outlet. So dito sa sa Manila, since mga 3-phase, highly recommended na to. Not only in the Manila, all over the Philippines, nire-recommend na yan na kapag mag-install ng outlet, dapat grounding type na. Kasi itong ground na to, napakalaki ng niya, purpose. So sa probinsya, kung walang grounding, so ang mapapansin nyo, mga outlet lang sa mga utility kung walang grounding. Dalawang lang, saksakan. Ito lang dalawang ito. Hot tsaka neutral lang. So yung ground, wala. Pero dapat meron para for safety.
a ground terminal. The casing of something like a washing machine is connected to a ground wire in the
Ayan, may mga case na yung ibang hindi nila alam ang purpose nito, tinatanggal yan. Hindi nila alam for safety yan.
lead, which goes to the plug,
So yan, yung mga plug na ganito, pinuputol itong pangatlo na to. So since wala naman saksakan na ganito sa ibang areas dito sa Pilipinas, so pinuputol to. Kasi yung kalimitang outlet natin, ito lang, anong tawag dito? 2-prong, 3-prong. So yung pangatlo, para sa ground yun.
through the receptacle and back to the panel to save you from an electric shock. Now, let's say you're outside with no shoes on.
So ayan, let's say sabi niya nasa labas ka. Tapos itong mamang ito, kung electrician man to, nakapa siya, siguro kampante siya.
And the ground or the soil is moist. If you touch a hot wire, you could complete the circuit and the
So ano mangyayari dyan? Nahawakan niya yung hot wire, nasuksok niya dun sa hot wire, dun sa outlet. Eh itong lupa na to is basa, masa-masa, tapos nakapaa. Anong mangyayari? Titrip ba yung circuit breaker o hindi? Yan tinatawag na katang na kuryente. Naka-electrician ka.
current may pass through you to get back to the supply.
So yun, yung flow, yung current, maaaring mag-flow from hot wire going dun sa katawan mo. So, ayan, makikita niyo yung mata, bilog na bilog. Ibig sabihin na kuryente yan. Kasi yung tao, mataas ang resistance nito compare dun sa ground wire na kung let's say dito sa ground, walang ground dito. let's say kung may ground wire dyan tapos nadikit dito sa receptacle or dun sa metal enclosure ng outlet, dapat dun dadaan yung current. Since wala tong ground, nahawakan itong mama na to, ayun o, umitim na yung mata niya, ibig sabihin ng kuryente na yan. Dito sa kanya magpo-flow yung current pabalik dun sa source. Since mataas yung resistance dito sa tao tsaka dito sa ground, sa lupa, so mabagal yung flow of current, mahihirapan siyang bumalik dun sa source. So ang babalik na current dito mababa lang, makukonsume dito sa resistance. So ang mangyayari, makukuryente to.
In this case, the resistance is going to be very high, so the current might not be high enough to automatically flip the breaker and cut the power.
So ayan, kapag mataas yung resistance mo dito, so pagdating dito sa circuit breaker, mababa yung current, so hindi niya matitrip tong circuit breaker na to, since mababa lang yung current na babalik. Pero kung dun yan dumaan sa ground, kung may ground ka dito, ground wire, pabalik dun sa let's say nagkaroon ng line to ground fault, so matitrigger niya tong breaker, matitrip niya. So in this case, hindi safe tong mama na to.
This will likely lead to the person's death. Luckily, we have the GFCI receptacle.
So ayan, ito magandang breaker to kung meron tayong may install na ground GFCI, ground fault circuit interrupter. So siya yung mag-i-interrupt kapag may na-detect na fault. So let's move on.
Or the GFCI breaker. GFCI stands for Ground Fault Circuit Interrupter.
Ayan, ground fault circuit interrupter. So ibig sabihin, i-interrupt niya yung ground fault. So let's forward.
We're going to look at a circuit breaker version, but essentially they're going to work the same. This GFCI breaker is going to be connected to both the hot and the neutral of the circuit.
So ayan, ito, this breaker, GFCI type. So maganda tong breaker na to, medyo mahal lang siguro to. Dito sa Pilipinas wala yatang ganito. Pero parang tinanggal na yata yun sa Philippine Electrical Code. May mga issue ako nababasa niyan sa social media. Tinanggal daw yata to sa Philippine Electrical Code, pero hindi ko pa nababasa yung Philippine Electrical Code. Okay, forward na tayo.
Circuit, so we can monitor the wires and ensure that the current running in the hot wire of the circuit is equal to the current running in the neutral wire of the circuit. If the current is not equal in these two wires, then it is clearly flowing back to the source.
So ayan, so yung function ng ground fault circuit interrupter, kapag na-detect nung ground fault, may sensor kasi yan yung GFCI. Kapag na-detect niya na unbalanced yung current, hindi equal, let's say mayroong leakage current, masesense niya na bakit yung bumabalik sa akin kulang. Parang ganito kasi yan, drawing ulit natin. Okay, so yung GFCI kasi parang ganito yata yung drawing niya. Okay, GFCI kasi, let's say ito yung line mo. Ano lang natin, nasimplihan lang natin yung drawing. O kaya ito yung neutral. So let's say ito yung GFCI circuit breaker. Tapos ito yung load. Correct me if I'm wrong. Correct me if I'm wrong. So simplihan lang natin yung ganito kasi yung understanding ko sa GFCI. Let's say ito yung GFCI mo. GFCI. So may particular sensor yata yan. So basta may sensor yan na nade-detect niya connect din yun dito sa let's say kung meron niya nakasawsaw dyan sa neutral. So dito nandito si mamang chukar. Okay, nakapamewang. Yan, nahawakan niya to. Let's say may naka-install dyan na outlet, nasuksok niya yung kamay niya. So yung current dito napapasok ay assuming na yung ito meron siyang resistance yan. Ano lang natin circuit circuit analysis lang. Dito mayroon ka ding certain resistance sa neutral wire mo pabalik sa source. So dito yung source mo. So itong GFCI na to madidetect niya yung current dito yung pabalik sa source. Ay since nahawakan niya dito, so mayroong flow of current dito. Let's say ito is I1, tapos ito I return, I supply. Para hindi mag-trip itong GFCI mo, dapat kasi para hindi mag-trip yan, yung IS mo is equals to IR or may certain na tolerance. So since in this case may iba yung hindi na siya mag-equal yung IR mo dito. Bakit? Kasi yung ibang current magpo-flow dito sa tao na to. So mangyayari diyan yung IS mo hindi na siya equal to IR. Mangyayari diyan I1 mababawasan yung IR. So magkakaroon siya ng I1 plus IR. So yung IR mo equals to IS minus I1. So ibig sabihin yung current dito sa return madedetect nitong certain sensor na to or parang parang clamp current transformer CT or clamp ammeter na sasabihin niya dun sa i-command niya tong GFCI kasi madedetect niya na hindi na equal yung current na pumasok dun sa lumabas. Ibig sabihin merong leakage na current. So ang leakage current ito, saan pumunta yung leakage current? Dito sa mama, nakuryente na siya. So ang tendency kapag unbalance yung current, hindi na meet to, kung may certain percentage tolerance yun sa setting ng GFCI, magti-trip ngayon itong GFCI kasi hindi nga balance. Meron kang leakage current or ground fault. So itong leakage current na to is line to ground fault. Bakit? Kasi itong mama na to nakatapak na yun sa ground. So yun yung basic na understanding ko dun sa GFCI. So balik na tayo. Pwede nyong i-check sa internet kung tama din itong explanation ko para maliwanagan kayo. Pero most likely tama yan.
Source via another route, we then have a ground fault. The breaker will realize this and very quickly and automatically flip to cut the power and kill.
So ayan, nahawakan niya to, automatic mag-trip yung breaker kasi GFCI breaker yan. Na-detect niya na merong fault, ground fault.
The circuit. Connected to the main panel, we will find a thick copper wire which leads out to a ground rod. The ground rod is buried into the ground outside near the property. This rod is not used for ground faults. Its purpose is to dissipate static electricity and external.
So yan, nagkakabit din ng ground rod. So ang purpose ng ground rod is i-dissipate yung static electricity from dito. Ayan, puti pa. Kidlat. So yung mga static electricity. Kasi yung kidlat, ang source niya, earth. So ang tendency niya, bumalik din sa earth. Kasi yung current, sabi ko nga kanina, kung saan ang galing, doon siya bumabalik. Ay yung kidlat, ang source niya, earth. Babalik din siya sa earth, which is through the ground rod.
External high voltages like lightning strikes. There is also a ground rod connected to the neutral.
So meron ding case na, ayan, may ground rod from dito sa, let's say, yung transformer side, nakatap sa neutral, diretso dito sa ground rod. So ang purpose nito, yun nga, pag may lightning strike, tumama dito diretso, so hindi na magpo-flow dito sa circuit mo papunta dito sa ground na to. Bakit? Kasi yung lightning strike, very high current yan, so hindi mo na kailangan hindi mo na nanaisin pa na dito yan mag-flow para lang makapunta dito sa ground rod mo dito. So ang tendency dito sa pinakamalapit na ground rod, dito siya magpo-flow para yung circuit mo dito hindi na masunog o hindi na masabog.
At the transformer. Many people think that during a ground fault, electricity flows through the ground rod and into the earth. But remember, electricity tries to get back to its source. It doesn't just go into the earth. And as there is a ground rod at the transformer, then there is a potential path for the electricity to get back to the source. But this path will have
Potential path between the rods is very high resistance. So dito medyo mataas yung resistance sa ground compared dun sa neutral or saka dito sa ground pabalik ng source.
Have a very high resistance or impedance. And as we know, electricity will take preference over the path with the least resistance.
So ayan, balik sa source kung saan yung pinaka less resistance. Much easier path available through ground to neutral, back to source.
So as we already have a very low resistance ground wire, which provides a path directly back to the source, the ground, so lightning is always trying to get back to its source, which is the earth. If lightning strikes the utility cables, it will flow along the wires to get to the ground rods of both the...
Sabi niya, the source of lightning is the earth. So yung nabanggit ko kanina. So it tries to return to the earth via the ground rod. So yun. Yung yung lightning magpo-flow dito sa wire papunta sa ground rod. Yan. So kung wala ka niyan, dito yan magpo-flow sa hot wires mo. Kung wala ka ditong ground rod, kung wala kang ground or neutral. So ang tendency, sunog tong breaker mo. Instantaneous yan. Otherwise, meron kang protection para sa lightning strike. Meron kang lightning arrestor diretso sa ground.
The transformer and also your main panel. And it's going to do this to try and get back into the earth. If it wasn't for this, then it's going to blow all our circuits and it's going to cause house fires. Now, if the hot wire came into direct contact with the ground,
yeah, sabi niya, if the hot wire was connected directly to the ground rod, it could return via the two rods. This would be a high resistance that breaker likely would not trip. So yan, pag mataas yung resistance
rod, then electricity will flow through.
So mababa yung current. So hindi niya matitrip yung breaker.
Through the soil back to the transformer, but the resistance is very high, so the current will be low. This means the circuit breaker will not likely detect the fault and the circuit breaker will not automatically flip to cut the power. Okay guys, that's it for this.
So ayun, tapos na yung dun, yung simple explanation niya. So recap tayo. Ano yung sulat natin dito? Ano yung ground? Pinag-uusapan natin is ground, neutral, tsaka hot or line 1, line 2, line 3 kapag 3 phase. So yun lang yan. Meron kang transformer, XMER. let's say 3 phase. So meron ka ditong Y connected secondary. Gawin natin 3 phase para medyo maganda yung tsura. Let's say yung delta o kaya Y din, pwede rin yung Y dito. YY. So meron ka dito neutral, pwede rin yung primary mo delta. So ito yung neutral mo, ito yung hot number 1, hot number 2, hot number 3. So yan, tapos meron kang ground ka dun sa transformer. Yan, nakatap yung ground. So yan yung tinatawag na 3 wire plus neutral plus ground. Bali 5 wires na siya. O kaya 4 wire plus ground. So ang pinagkakaiba niya, mga gets nyo naman, basic lang. Yung neutral, under yung neutral wire, under normal condition, siya yung magkikiri ng unbalanced current. Normal. Abnormal condition, yung abnormal. Ganang pa dyan, madami dyang abnormal. So abnormal, ito yung may fault na. Meron ka ng ground fault or line to ground fault. Line to ground fault. Ano pa? Line to line fault. Pag line to line fault, so it's another discussion. Yung mga fault na yan. So dyan napapasok yung fault calculation, short circuit calculation. So yun lang, very basic lang yung yung pinagkaiba-iba ng tatlo. So hopefully nung napanood yung video ng engineering mindset saka itong explanation natin, na distinguish nyo na kung ano yung pinagkaiba-iba ng tatlo: ground, neutral, tsaka hot. Okay, thank you for watching. Sana kahit papano meron kayo natutunan sa video na to. So hanggang dito na lang muna, at see you sa marami pang video na paparating. Babush!